recorded some stuff here today, but I haven't checked to see if the audio is still working, but hopefully it is. This isn't a big waste of time. Usually I do lesson 81 and 82 together, but we're already way behind and to the point where I'm not trying to push us forward faster, especially considering that we're in a time where a lot of people are out sick. It's not really going to benefit the class to move in at a double lesson pace. Lesson 81 is a lot of review. It's talking about graphing and solving linear systems. Graphing and solving linear systems, what we're saying is that this is the place where these two lines connect. These are where they intersect. So a system of equations is a set of two or more, or doesn't really need an E there. We're not talking about like minerals, so let's fix that up. Two or more equations that have two or more variables. All right, we can have systems of three variable equations. Systems of linear equations can be solved algebraically or by graphing the lines. Right, so we've already kind of done this. Right, so we're going back. So lesson 81 is a lot of review, and we only really have one other slide. If the lines are graphed, the solution of the system is the coordinates to the point where the lines intersect. So if we plug this in our graphing calculator, or we actually had both these equations in slope-intercept form, and I graphed both lines, my solution would be where those two lines intersect. Does that ring a bell? We knew that already, correct? Wobble our heads up and down. Yes, got that. All right, if we're solving algebraically, this is where we would set two equations equal to each other, or solve through elimination, or whatever we would do to end up solving, say, for x. We would take our x, we'd plug it back into one of those equations, solve for y, and the x, y that we have would represent our coordinates where those two lines cross. That would be my solution. Does that make sense? All right, so it's where the two equations would actually equal the same value. So at this point, without further ado, we're just going to go in and we're going to look at some of these questions and see if we can solve them. So this question, question number 1, says solve the systems of equations algebraically. So we have looked at like 5 or 6 different ways to solve something like this. We can solve through elimination, right? Right? What does it mean to solve through elimination? Anybody know? Right. So we could say, if we want to solve through elimination, I might go over here and I'd say 1x plus 5 and put that over 6x minus 5 and do what with those two equations? I'd want to eliminate something, right? Eliminate the 5 through what? Addition or subtraction? Well, actually, if I end up subtracting, right, it's going to make that double subtraction, right? I would end up taking 5 minus negative 5, and I'd get 10, right? So what do I actually want to do there? Add. I want to add. So 5 plus negative 5 cancels out, correct? Okay. So that's going to cancel those out. So I'm going to get 1x plus what? 6x. So I'm going to end up getting 7x. All right. So we're getting 7x equals y. Right, and it'd be more helpful. Let's see. Actually, what we'd want to do here, and this is where I make a mistake, and so you get to see this on video then, I guess. But we actually, in order to solve by elimination, we need both our variables set together. So this would be better served as y minus 1x equals 5. My deal's not very great there. And y minus 6x equals negative 5. And then we would add those together. Or even subtract, because what we could do here is eliminate our y's. Y minus y cancels out. Negative 1 minus negative 6x is what? What's negative 1 plus 6? Negative 1 plus 6. 5x. Right? What's 5 minus negative 5? 10. What do I do with my 5? Divide on both sides. What does x equal? 2. 10 divided by 5 is 2. Then I can go back in here, right? Once I know that x equals 2, we can say y equals 1 times 2 plus 5. What is 1 times 2? What is 1 times, somebody said it, 2. What's 2 plus 5? 7, so y equals 7. So what are my coordinates then? 2, 7. So I'd get D there. Okay, that's how we would solve algebraic. Sorry for the confusion at the beginning of that. Do we understand how to do this? Right. Other methods that we've used to solve these are Cramer's rule. I'll just give you another instance. Do both of these equal y, right? Yes. So let's look at something else here. We could have done 1x plus 5 equals 6x minus 5, right? Yes? Because they both equal the same thing. They both equal y. So I could add 5, and I could subtract 1x, and this is essentially doing the same thing that we just saw, but that's going to be 10 equals 5x, x equals 2, plug it back in, we'll do it again. All right? So we understand how to do this. Okay, there's a couple different methods that we can use for these. All right? All right, so we should get D for an answer there. Let's look down here at number 2. We want to solve this by graphing. If I wanted to graph those, do I like the way that those equations work? Or look, sorry. Erica, you were shaking your head no. What would you want out of those equations? What kind of form would you want to put those in? Sloped intercept form. All right, so that means y equals something x plus or minus, so on. Could I take x plus 3y equals negative 21 and convert that? What would I need to do with the x? Subtract it. So I would end up with 3y equals negative x minus 21, right? Then what would you do? No, because look, we're already pretty close to having y equals something x plus or minus something. The only thing that's keeping this from being y equals is what? No, the 3. How do I get rid of that 3? Divide by. All right, so divide by 3. So we're getting something along the lines of y equals negative 1/3 x. What's negative 21 divided by 3? Negative 7. Can I graph y equals negative 1/3 x minus 7? Okay, what's the y-intercept there? Negative 7, right? So it should be below negative 5 and above negative 10. And it's got a negative slope, right? So it should be going down. So we can see that A isn't going to work, right? That doesn't even match my first line. Looks like C might match my first line. Let's see what these others look like. Let's see. Notice that it has the B has the y-intercept at negative 7, but notice that it's a positive slope. So is B going to work? No. Look at D. Does it have a negative 7 y-intercept? No. Right, so I could tell right off the bat that C is probably my answer. All right. But the other thing, again, if we want to continue to graph, what do I need to do with the second equation? Caleb, what do I need to do with the second equation in order to graph it? Solve for y, right? So what are we going to do to solve for y with this one? So you'd get 4y equals 2x. You'd add 2x equals, minus 8. What would you do next? Divide by 4. All right, so y equals 1/2 x minus 2. Okay, so it's got a y-intercept of negative 2, but it looks like it's got a positive slope, right? So I would plug those two equations in my graphing calculator, and let's see if it looks like C. Okay, let's turn this on. Y equals, clear out some information here. Okay, so we're going to have 1/2 x minus 2. And we're going to come down here. We've got negative 1/3, so negative 1 divided by 3. X minus 7. Let's graph those. Okay, so far that looks good. And we can look at this point of intersection over here, right? It should intersect at -6, -5. And I don't know that they're going to, it's a little different here. So let's see if we go to -6, right? Notice that if I do a table of values, right, I'm looking for the x value where the y's are the same. So notice as I get to -6, both of those say -5. Okay, so same input, same output. Does that make sense? That's how I would check a table of values in a graphing calculator to see where they cross at. All right, everybody with me? Perfect. All right, let's clear this one up. Let's go down to number 3. All right, this says determine the number of solutions. Let's see, where is... Well, in any case. Okay. Number 3, determine the number of solutions. We got y equals -3x minus 10. And we got -3x minus y plus 5 equals 0. Okay? So what do I want to do with that second equation? Anybody tell me? Aaron, what do you think we would want to do with that second equation? We've got our top one. It looks fine. What do I want to do with the lower one? Okay, can you help me out with that? What would you do first? No, we don't want to solve for x. Notice that in our slope-intercept equation, what is it always solving for? Y. So we want to solve for y, which means we need to isolate y. How would you isolate y there? Move everything else to the other side, right? What would be the easiest thing to move to the other side? 5. How would you move it? Subtract. So you'd end up with -3x minus y equals -5, right? What else do we want to move over there? Yeah, the -3x. How do we move -3x to the other side? Add 3x. So that's going to give me -y equals 3x minus 5, right? Okay? I still need to move one more thing. Do you know what it is? The negative. How do I move the negative? That's kind of a tricky question. What coefficient exists in front of a variable if I don't see the number? 1. So let's draw that, see if it helps. How do I move the -1? No. No. Because notice how it's right next to it? Divide. Divide by -1. We're actually dividing everything by -1. So y equals, what's 3 divided by -1? Anything divided by -1 is, it ends up going, it's going to end up being -3x, right? -3x, and so what is -5 divided by -1? Negative divided by negative is a positive, so you get +5. So we've got an equation. We got y equals -3x minus 10, and we have y equals -3x plus 5. Let me ask you this question real quick. Are those lines ever going to cross? Yes or no? It's just simple yes or no. Do those lines cross? Somebody said no. Matt, did you say no? You said no. Why will those lines never cross? Same slope, but what? What's different? Different y-intercept. What does that mean about those two lines? What are they? They're parallel lines, and parallel lines never cross, right? So if a solution to two linear equations is where they cross, and we have two lines that never cross, is there a solution? No. So we're going to say, does it have infinite solutions? No. Does it have no solutions? The equations represent parallel lines. Do we see and understand that? So one of the first things I want to look at whenever I see an equation is it in y-intercept form? If it's not, can I convert it? Right? Now, notice that it says has infinitely many solutions. When would I get infinite solutions? Anybody know? When would I get infinite solutions? How can I get infinite solutions? Miss Ayel, what do you think? If I get no solutions with parallel lines, when would I get infinite solutions? When they cross more than once. But when do two lines cross more than one time? I mean, they're lines. It's not like a curve where it's coming back through itself. Any hints, clues? When they're what? When they're the same line. If we had solved this and it had come out to this, right, where it's negative 3x minus 10 and negative 3x minus 10, whenever I went to graph them, would I end up graphing the same line over the top of itself? Which means they intersect at absolutely every point, which is infinite, right? That would have infinite solutions. So whenever two lines equal the same line, there's infinite. When two lines are parallel, there's no solution. If two lines have a different slope, okay, so long as they have different slopes, there's going to be exactly one solution, right? Two lines will never have. Two lines will never have two solutions. Your options are one, none, or infinite whenever you're dealing with linear equations. Does that make sense? All right. All right, number four. The Fun Guys rental store charges an annual fee of $5 plus $6.50 per game. What does that say? Game Bank charges an annual fee of $21 plus $4.50 per game. For how many game rentals will the cost be the same in both stores? What is the cost? We've solved questions like this before, right? What do I do? I know we've solved these questions. What do I do? Can I take $5 plus $6.50 per game and write an equation for that? What do we mean? How would I write $6.50 per game? 650x, right? Is that what you're getting at? All right. Plus 5. Very good. Plus 5. All right. We want to know when the cost will be the same. So what am I doing with two equations? Setting them equal to each other. What am I setting that equal to? 4.5x plus what? 21. All right, now I'm just solving for x, right? X represents the number of games. What do I want to do here, Austin? Combine, well, kind of. I need to get my x's together, right? Because I want to solve for x. How do I do that? Well, if I add 4.5 to both sides, I'm going to wind up with 9 over here, right? I'm going to wind up with 9x. That's not exactly moving my x over. Subtract it. All right, subtract 4.5x from 6.5x. Okay? What do I want to do with that 5, Nick? That 6.5x plus 5. Can I get that 5 over to the other side? Subtract it to the other side. Should give me a list of positive values. What's 6.5 minus 4.5? 2x. 2x equals what? What's 21 minus 5? 16. Right? Divide by 2. X equals 8. So whenever I rent 8 games from either place, my cost is going to be the same. And then they're going to ask, what is that cost? All right. So what do I do with that x? Does it matter which equation? Shouldn't. If I've done it right, it shouldn't matter. So we're going to take, you got a calculator there real quick. Take 6.5 times 8 plus 5. Tell me what you get. Now, I know that there's only 4 answers. Only one of them says 8. So it should be what? Should be 57, right? All right. But if this question is on a test, are you going to have to show me how you got 57? Yeah. You're going to have to show me how you got it. So you're going to have to show me that you plugged 8 back in. All right, number 5, solve the system of the equations below algebraically. So what's the easiest thing to do here? If I want to solve them, notice that they both say y equals, what's that? Set them equal to each other. So negative 2/3 x plus 2 equals 4/3 x minus 4. Now, I'm going to show you a trick here because notice that both of these are dealing with fractions. Do I really want to add fractions to each other. This is going to make it a little bit more difficult. All right, so what I can do is I can multiply the whole thing by the common denominator, right? So can I multiply everything by 3? Right? Let's see what I would get if I multiply everything by 3. What's 3 times negative 2/3? Well, what's 3 times negative 2? Negative 6. What's negative 6 divided by 3? Negative 2x, right? What's 3 times 2? 6. What's 4 times 3? What's 12 divided by 3? 4x. What's negative 4 times 3? Negative 12. So what that does is it gets everything into whole terms, but doesn't change the value of either equation. Does that make sense? Does that get it a little easier? Now, if this had been a 3 and this had been a 2, I would have multiplied by a common denominator out here, which would have been 6, and that still would have given me whole numbers. Okay? Does that make sense? All right, but because it was 3, I could multiply by 3. From here, minor, how would you solve for x? Subtract 6 from 12. Okay. Oh, well, that's going to move everything over there. If you're going to subtract 6, then you have to subtract 4x. My suggestion is that I want to keep things positive as much as possible, right? That way I don't end up having to divide by a negative in the end. Add 12, okay? And do what? Do what with this 2x? Add 2x to both sides. All right, what's 6 plus 12? 18. And what's 4x plus 2x? 6x. What does x equal? 3. All right, are we done? No, we do know that we have 3. What do I need to do with x equals 3? Plug it into an equation and solve for y. All right, my suggestion is I'm still going to pick probably one of these whole equations. I'm going to pick something without a negative in it. We know that x equals 3. Can I do 4 times 3? What's 4 times 3? What's 12 minus 12? 0, so y equals 0. All right, so the solution is 3, 0. You follow? Okay, we're feeling pretty good about this so far. Okie doke. Am I going too fast for anybody? I feel like I'm talking quickly. Did take a 5-hour energy drink this morning, so. All right, what are we going to do here? Similar thing? Okay, Brady, walk me through it. Okay, what would you do to make your life easier here? Multiply it all by 4. Okay. What's 4 times 5? What's 20 divided by 4? So could I write 5x there? What's 4 times 3? 12. Okay, what's 4 times 1? What's 4 divided by 4? 4 divided by 4? 1. All right, so I could just write x there. What's negative 1 times 4? All right, does everybody understand how we did that? Okay, multiply the number times the numerator and divide by the denominator. Okay, so we have 5x plus 12 equals x minus 4. What do you want to do from there? Subtract x from both sides. Okay, I'm going to bring this down here, so that's 4x, right? What are you going to do with the 12? All right, so what's negative 4 minus 12? Negative 16. And the thing you need to understand is sometimes getting a negative number is unavoidable, right? What am I going to do with the 4? Divide on both sides. What is x? Negative 4. Good. Okay, so x equals negative 4. I want to solve for y. Okay, now this did say solve by graphing, but we're solving algebraically, and I think you guys know how to solve by graphing, right? All right, could we plug this in a graphing calculator later and figure that out? Okay, what do I want to do with this? And I'd probably plug it in the short of the two equations. So what's negative 4 minus 4? y equals -8. All right, let's come over here real quick just so that we see how this works. Let's do our y equals. And I'm going to take our equations that we actually solved and reduced down. 5x plus 12 and x minus 4. Let's graph those. Does it look like they solve at -4, -8? Kind of. All right, let's check. We're going to go to -4. Let's see, do they have the same y value? Yep. Okay, so for a common input, they have the same output. They have the same y value, right? So that's how I would check on that graph in a graphing calculator. Does that make sense? Okay, hopefully we can remember how to do some of that. All right, so we actually solved that one algebraically and by graphing. Okay, 7. The supply curve for a product is represented by the function y equals 1/3 x plus 40. The demand curve is represented by the function y equals -1/7 x plus 60, where y is the price of the product in dollars, x is the number of units sold. What is the optimum price of the product? So, and how many will sell at this price? So again, you're solving for x, solving for y. Does that make sense? Okay, have we already done this? Right? All we're doing is what with these two equations? Setting them equal to each other. All right, so we can write 1/3 x plus 40 equals what? -1/7 x plus 60. All right, well, these aren't both 1/3 and they're not both 1/7. So if I want to multiply these to simplify them a little bit, what would I multiply them by? I can multiply them by 21. Is there anything smaller than that that we could multiply them by? Doesn't appear to be, right? So let's try times 21. What's 21 times 1? What's 21 divided by 7? Or sorry, 21 divided by 3? 7, so that's going to give me 7x. What's 40 times 21? That's probably a pretty big number, right? 840. All right, what's 21 times -1? Probably -21. What's -21 divided by 7? -3x. And what's 60 times 21? 1,260. I'm going to take your word for it. Okay, what do I want to do here? Subtract 840. Okay. Anything else while we're here? Add 3x. Okay, add 3x. What's 3x and 7x? 10x. I'm going to set that off over here because I'm running around. What's 1260 minus 840? 420. All right, what is x then? 42. Okay. Now we just need to solve for y. How do I solve for y? Plug it in. Does it matter which side I plug it into? I'd probably plug it into the 7x plus 840. That way I don't have to worry about missing that -3. What's 7 times 42 plus 840? Let's see. 1,000. Hold on. Yeah, I'm trying to figure out how I ended up with a smaller number here. Let's try this with our original equation. Let's do 1/3. 1/3 times 42 plus 40. So 1 divided by 3 times 42 plus 40. 54. Okay, 42 and 54. So our optimum number sold is going to be 42. Our optimum price is going to be $54. Okay, how many will sell it at this price? 42 will sell at that price. Our optimum price is $54. Does that make sense? All right, so with that one, you do want to make sure that you plug it back into one of the original equations so you don't wind up with a huge number because obviously, you know, what was our number? It was some great big deal. It's probably not going to sell at that price, so we need to go back into our original. All right. All right, number 8, determine whether there's a solution to the system of linear equations below. If not, explain why not. Okay. What do I need to, are both of these equations ready to go, or do I need to do something? Change the second equation to what? Okay, what do I need to do? Subtract 2. So you got 3y equals 6x, what, minus 3? Is that right? Divide by 3. So I got y equals what? 2x. So it's what? Minus 1. Negative 3 divided by 3 is 1. How many solutions are possible here? Remember, this is 1, right? They have different slopes, right? The y-intercept doesn't really matter. Just the fact that they have different slopes tells me I'm going to get one solution. They will cross at some point. And we don't have to, it just determines whether or not there is a solution. They're not asking for that solution. Okay? Let's see. All right. All right, last question. All right, I'm going to hit pause, or actually I'm going to hit stop on the video. I want to see you guys solve this question on your own. I'm going to come around and check. You guys have got it. Then you guys can get started on your homework.